Welcome to the session of NEET Bytes. Welcome everyone in the session of NEET Bytes. Today we are again starting this chapter thermodynamics. In the previous class, we are discussed about first law of thermodynamics and its application. Today we'll study about the heat engine and refrigerator, right? So good evening everyone. Good evening Khushi and Famous who's there and and Muhammad Ayaz, Radha Singh and everyone. Welcome to the session. So, dear students, let me tell you something about engine. What does engine do? What's the role of engine? Heat engine. First of all, we should learn about heat engine. Any idea what is heat engine? What does it do? What does it do? It actually converts heat energy into mechanical energy, right? So that's what it does. So heat energy into mechanical energy, right? So there is, let's say, a sink. Let's say this is a source. There must be a source of energy. There must be a source of energy, right? And there's a sink to which the heat is discarded, the extra heat is discarded. And heat engine, what does it do? It takes a heat from source and converts it into work, okay, and discards the extra amount of heat to the sink, right? So let us say that source is at temperature T1 and sink is at temperature T2, and Q1 amount of heat is taken from source and Q2 amount of heat is rejected to the sink. So the efficiency is calculated. Now student, you can understand from here that Q1 is a source, Q1 is energy coming from the source, right? And Q2 is energy going to the sink. So you can say that Q1 is equal to Q2 plus W, right? We can say that, yes or no? Very easily we can say, because Q1 amount of work, so energy is coming from source and Q2 is going to sink and W is the amount of work, right? So now, see, now if you have to find the work, what is the work? Work is Q1 minus Q2, okay? So you see, what is efficiency? Efficiency is always measured in the terms of output by input. What is the output here? Output is the work done. Okay. So this work done is the output. And what is the input? Q1 is the input. So W by Q1 is the efficiency into 100% you say is the efficiency. So we say that it's equal to, efficiency is equal to Q1 minus Q2 over Q1 multiplied by 100, and that's in percent. Okay. So eta is equal to 1 minus Q2 over Q1. This is the formula for efficiency, right? And what you have to do now, you see, Q2 over Q1 is equal to T2 over T1 under ideal condition. Okay, under ideal conditions, this is like this. Okay, or you can even prove that Q1 by T1 is equal to Q2 by T2. This happens under ideal condition. Okay, so we can write from here, what we can write? We can write efficiency as, what we can write about efficiency? Efficiency becomes eta is equal to 1 minus T2 over T1 by into 100 This is the efficiency or heat engine. Okay. Now let's solve one question over it. The efficiency of an ideal heat engine working between the freezing point and the boiling point of the water is. So what we have to find? We have to find the efficiency. Okay. And write what formula we have written. It's equal to 1 minus T2 by T1. What is T2 and what is T1? Anyone can please tell what is T2? T2 is the temperature of what? T2 is the temperature of sink. And T1 is the temperature of source. Okay. Temperature of source. Okay. So from this given question, what we can say? What is T2 here? T2 is equal to how much? Now see, you should be clear about that. Heat engine takes heat from a source, so the source must have a higher temperature. So T1 is equal to the boiling point of water. And what is that? That is 100 degrees Celsius. Now, whatever temperature you have to write in kelvins. Okay. So 100 plus 273 you have to write. You should write it as what? 100 plus 273. Okay. 100 plus 273 in kelvins. What is T2? It's a freezing point, and that is equal to 0 degrees Celsius, and 0 plus 273. This is the T2. Okay. So eta is equal to 1 minus T2 over T1 into 100%, right? So from the above equation, we can say eta is equal to 1 minus, what is T2? It's 273 divided by, what is the temperature of source? It's 373 into 100%. So very good. Who's saying? Yeah, Anjali. Very good, Anjali. And the remainder and the truth. Yes, the truth is that the correct answer is A. So from here we can say it's 100 over 373 into 100%. And what do you get after that? Eta is equal to how much? You can calculate the value, students. You'll get 26.8%. Correct? So A is the correct answer. Okay. So similarly, as we have heat engine, similarly we have refrigerator. What does refrigerator do? Anyone can please tell what is the work of refrigerator? What does it do? What is the function of refrigerator? Please tell. Anyone? Let's talk about refrigerator. Okay. Let's talk about refrigerator. So a refrigerator, it's the opposite of heat engine. Okay. It takes the heat from the sink and gives it to source. Or you can say it takes the heat from you say source, which is having low temperature, okay, low temperature, and gives it to the surroundings that is at high temperature. So now this is not spontaneous. Okay, this is not spontaneous. You see, always heat flows from higher temperature to lower temperature, right? Heat always flows from high temperature to low temperature. This thing is spontaneous. It happens by itself. But this is the opposite. Heat cannot flow from low temperature to high temperature. This is not possible. So for this, what you have to do, you have to supply the work. Okay, you have to do the work. So if you do some work over it, only in that case you can transfer heat from low temperature to higher temperature, right? So for a heat engine, if you say for a heat engine, let's take similar things. Let's take this is the surroundings. This is a sink, okay? This surrounding, okay? And you can say it's sink or whatever. It's always at low temperature, right? So this is the refrigerator in the middle. Okay. So it takes the heat from sink. It takes the heat from sink. Let's say that is Q2, and gives that to surroundings. Let's say that is Q1. Okay. And it does some work. Okay, some work has to be done. Okay. So from here also you can see Q1 is equal to Q2 plus W. Okay. So students, this Q2 by W, this Q2 by W is known as beta, or the coefficient of, it is known as coefficient of performance. Okay. So this is coefficient of performance. Okay. So its relation with efficiency and temperature is as, see, beta is equal to T2 by T1 minus T2. Okay. And it is equal to Q2 by W. Okay. You can also say W is equal to W1 minus, W is equal to Q1 minus Q2. Okay. So these are the two formulas that are important for this refrigerator. Okay. These are coefficient of performance. Coefficient of performance. And further, if you write beta and efficiency, they are related as 1 minus eta over eta. Okay, beta and efficiency, or the coefficient of performance and the efficiency, they are related like this. Okay, they're very important formulae for the refrigerator, and we have direct application of these formulae. Okay, so let's see this question. A Carnot engine having efficiency 1 by 10 as heat engine is used as a refrigerator if the work done on the system is 10 joules. The amount of energy absorbed from the reservoir at low temperature is. What you have to do? See, in this question, what is given? Efficiency is given. Okay, efficiency is given. From efficiency, what we can calculate? We can calculate beta, because we know the relation between efficiency and coefficient of performance, and that's equal to 1 minus eta by eta, right? So beta is equal to 1 minus 1 over 10 divided by 1 over 10. So from here, you can write beta is equal to 9 by 10 divided by 1 by 10. So this implies it's equal to 9. So beta is equal to 9. Okay. So beta is equal to 9 here. Now, what we have to find now, given that the work done on the system, okay, so this is the work done on the system, that's W, right? The extra amount of work done in a case of refrigerator, W is equal to how much? It's 10 joules, correct? So what we have to find? The energy, amount of energy absorbed from the reservoir. Okay, the amount of energy absorbed. So this is Q2. Okay, amount of energy absorbed. Okay, you see in the last case, you see, as I told you, what is beta? It's equal to Q2 by W, or Q2 by Q1 minus Q2. If you just see the diagram, okay, sink or it's the reservoir of the heat. Okay, so here you can see Q2 is the amount of heat absorbed. So we have to find that, right? So Q2 over W, Q2 over W is equal to beta, and that is equal to 9. Okay, so Q2 Q2 by W, what is W? It's how much? How many joules? It's 10 joules. So 10 is equal to 9. So Q2 is equal to 90. 90 joules of energy is absorbed from the reservoir. So the correct answer is A in this case. In this question, the correct answer is A. Okay. So now let's move forward. The next question. Next question is also based on refrigerator. Okay. So what is given the question? Let's read the question first. The temperature inside a refrigerator is T2 degrees Celsius. So remember, whatever is placed inside the refrigerator, its temperature has to be decreased. Like the case I told you of the diagram. So sink is a temperature of sink, right? And the room temperature is T1 degrees Celsius. So this is what room is, what a surroundings, right? The amount of heat delivered to the room for each joule of electrical energy consumed ideally will be. Okay. So dear students, what is beta? Beta is equal to how much? It's equal to Q2 by W, where Q2 is the amount of heat absorbed and W is the amount of work done, right? So in this given case, what we are provided, we are given that temperatures are given, and that is equal to T2 by T1 minus T2. First of all, you should know that T1, T2, these are absolute temperatures. Okay, they are absolute temperatures. Okay. So you have to add 273 in this case, right? So T1 is equal to how much? It's equal to T1 plus 273, right? And in the other case, T2, you have to write small t2 plus 273. So that's what you have got in Kelvins. Temperature is now in Kelvins. Okay. Now, what is the beta? Beta is equal to, simply you can say it's T1 plus 273 divided by the difference of the two. So when you take the difference of the two, you'll get T1 minus T2, because the other thing is constant, it will get cancelled out. Okay. So the next thing. So dear students, what is Q2? What is Q2? Q2 is the amount of heat absorbed. Okay. So what we can say that this beta is equal to Q1. You see, what is the relation between Q1 and W? Q1 minus W is equal to Q2, right? Q1 minus W is equal to Q2, because we have written that Q1 is equal to W plus Q2. Okay. So from this, we can simply write this. Okay. So we can write beta as Q1 minus W divided by W. Okay. So we have to find what? We have to find the amount of heat delivered to the room for each joule of electrical energy. So we have to find the ratio. We have to find the ratio of Q1 and W. Okay. So from here, we can write this as Q1 by W minus 1 is equal to, and now we know the value of beta. This is the value of beta. So T1 plus 273 divided by T1 minus T2. So from here, what we can say Q1 by W is equal to 1 plus T1 plus 273 divided by T1 minus T2. Okay. So if you further solve it, you'll get Q1 by W is equal to T1 minus T2 plus T1 plus 273. And you can simply say, sorry, it should be T. Wait a while. What mistake we have done? It should be, okay, sorry. We have to write it to T2 plus 273 here. It should be T2 plus 273. It's T2 plus 273. Okay. We should write T2 plus 273 here. So here also we can correct it, because T2 temperature is written in the numerator. It's T2. So from here we can see this is T2. Just removing this part. So students, you can easily find the value of Q1 by W. What is Q1 by W? Q1 by W is equal to T1 minus T2, T1 minus T2 plus T2 plus 273. Okay. So T2 and T2 get cancelled. So simply we can say the correct answer is T1 plus 273 divided by T1 minus T2. Okay. The correct answer is D. So many of students have reached the D answer. So that's very good. Answer is D. That's correct. So the next question, students. A refrigerator works between 4 degrees Celsius and 30 degrees Celsius. Okay. It is required to remove 600 calories of heat every second in order to keep the temperature of the refrigerator space constant. The power required is, what we have to find? We have to find the work done. Okay. Work done per second, we can say. Okay. So here also we are given the heat that is released every second. Okay. So whatever value you will get for the work, that is the work or done in 1 second. So that's the power only. So first of all, we have to understand which is T1 and which is T2. Okay. What is T1, students? You can see a refrigerator takes heat from, let's say, some substance at temperature T2 and gives that to some substance at temperature T1. Okay. So T2 is always less than T1. T2 is always less than T1. So from here you can understand that T2 is 4 degrees Celsius and T1 is your 30 degrees Celsius, right? So from here we can say that T1 is equal to 30 plus 273. Okay. And that's in kelvins. And T2 is equal to 4 plus 273 in kelvins. Okay. Now, next thing is we have to find the power required. Okay. So we know that Q2 by W is equal to T2 by T1 minus T2. T1 minus T2, right? So from here, now students, Q2 is given in calories. So first of all, convert that into joules. Okay. So 600 into 4.2 divided by W. Okay. W we have. So what W we have to find from here. So what is T2 here? It's 277. And T1 minus T2 is how much? It's 30 minus 4, that's 26, right? So from here, we can say W is equal to 600 into 4.2 into 26 divided by 277. Okay. So when you calculate the value, now this is the value of what? Work done in 1 second. Okay, this is the work done in 1 second. So it comes to be equal to 236.5 joules. Okay, so joules per second, you get the power in watts. So 236.5 watt is the power for this given situation. So the correct answer is D in this case. Okay, students. So thank you so much for attending the session, students. So I hope you learned a lot today. And so to know more about Meritnation, how we can boost up your performance in NEET, you can see this given link. Okay. And for further information about NEET Catalyst, you can see the given link. It's also mentioned in the chat also. You can click on the link and get all the information about this NEET Catalyst course. Okay, it contains our AITS all-India test series. Okay, our some sample will also be given to you, and everything is in computer based. Okay, and previous year papers, daily dose. There's so many things that can really help you out in improving your performance in NEET. Okay, so all the very best to all of you. So thank you so much. See you.